So let's take a couple of fractions. Let's take the fraction 3/8, and underneath it I'm going to write, I guess I should say, I'll do it like this, 3/8, and actually, how do I want to do it? I think the way I want to do it is 3/8 on the top, and let's do 1/2 on the bottom. Now 3/8 represents some amount of stuff. How much stuff does that represent? Well, these are slices of eighths. This means if I take a circle and cut it into 8 equal slices, every one of these wedges is called an eighth, and we have 1, 2, 3/8. If you go all the way around to a whole, you'll have 8/8. This is only 3/8, so that's how much pizza we have right there. And we want to have as our second fraction 1/2 of a pizza, which you could orient it like this, or you can orient it like this, same thing. What we want to do is we want to figure out a way to express this much stuff and this much stuff in terms of the same denominator, the same size slice. Because you see, this is 3/8. The slices are very small. This is 1/2. The slice is really, really big. It represents the amount of pizza that's up there, but in order to add or subtract fractions later, we always want to have the bottom number, the denominator, the same. And so we're going to practice that skill here. Now, remember, the one thing that's probably one of the most important things that you can remember and learn about fractions is the following. You can change a fraction by multiplying or dividing the top and the bottom number by whatever you want, as long as you do it to the top and to the bottom. You can think of fractions as like balanced on a scale or on a seesaw. If I multiply the top by 2, I must also multiply the bottom by 2. It'll change the way the fraction looks, but it will not change what the fraction represents or means. I can also take and divide the fraction by 3 on the top, and divide the bottom also by 3. As long as I'm doing it to the top and to the bottom, I can multiply or divide by any number I want, and I don't really change the fraction meaning. I change the way it looks, though. So I can take this and I can multiply this fraction by anything I want, as long as I do it to the top and to the bottom. I can take this fraction and multiply it by anything I want, as long as I do it to the top and to the bottom. So what would be the easiest way to get these two fractions to have the same denominator, the same bottom number? This bottom number is an 8, and this bottom number is a 2. And I remember that 2 times 4 is 8. So I can very easily fix this problem, these different denominators, by just playing around with the second fraction only. I can multiply this fraction by 2 on the bottom, by 4 on the bottom, and also by 4 on the top. And when I do that, I will change the way it looks, but I won't change what it actually means. So let's do that right here. Let's take this 1/2. This is the way I want you to do it. I want you to rewrite the fraction 1/2 with a longer fraction bar. And on the top, I want you to write down that you're multiplying by 4 on the top and also 4 on the bottom. Remember, it's going to change the way it looks, but because you're doing it to the top and to the bottom, you're keeping everything balanced. So what do we have here? 1 times 4 is 4, and 2 times 4 is 8. So what we're claiming is that 1/2 of a pizza is exactly the same amount of pizza as 4/8 of a pizza. Does this make sense? Let's take a look at what 4/8 of a pizza would really look like. Well, here's 1, here's 2/8, here's 3/8, here's 4/8 of a pizza. Let me turn it like this, and you can see that 4/8 of a pizza is exactly the same. So what happened here is I started with this much pizza. I have a fraction that still means the same amount of pizza, but it just represented in terms of eighths in the denominator, in terms of slices that are the same slices as over here. So in order to find the common denominator, or find the pair of fractions that have the same common denominator, the answer to this problem is going to be the following. I'm going to write it, where am I going to write it at? I'm going to write it like this: 3/8, comma, 4/8. The question is asking, take the original fractions and find a pair of fractions that have the same common denominator. And this one, I'm leaving the first fraction alone because I did not need to change it. I only had to change the second fraction because I just realized that 2 times 4 is 8, and then it would match what I had before. So really what you're hoping for here is you're hoping to only have to mess around with one of the fractions. And the first few problems here, that's what we're going to do. Later on, we may have to change both of the fractions, but really all we're trying to do is get a common denominator, and hopefully a common denominator with the smallest bottom number that we can have. All right, so let's go a little farther and solve a few more problems. All right, let's take a look at the following two fractions. We have 1/4 and we want to find a common, a pair of fractions that have the same denominator that mean the same things as 1/4 and 7/12. Now I can multiply the top and bottom by this fraction by anything I want, and I can also multiply the top and bottom of this fraction by anything I want. But here, all I have to do is play around with the first one because I have a 4 and I have a 12. I just want the denominators to be the same. But I remember that 4 times 3 is 12. Then it'll match perfectly. So before we actually do anything, let's kind of like show what these actually mean. This is 1/4 of a pizza. That's represented by this. If you cut a pizza into 4 equal slices, that's what 1/4 of it looks like. And then this amount of pizza right here is 7/12. That's 1, 2, 3/12, 4/12, 5/12, 6/12, 7/12. So let me turn it sideways here. And you can see that 7/12 is just a little bit more than half of a pizza. So what I want to do, because remember, the reason we're doing this is because later we're going to add these together. And we want to have the bottom numbers the same in order to be able to add them. So how can I make these bottom numbers the same? I'm just going to play with this fraction. I'm going to multiply by 3 because 4 times 3 is 12. So let's go ahead and do that. We're going to say, well, we're going to go and have 1/4. We're starting with the fraction that we were given. And we're going to multiply the top by 3. And that means we must also multiply the bottom by 3 in order to have the same fraction. All right, so what do we have? On the top, we're going to have 1 times 3 is 3. And on the bottom, we're going to have 3 times 4, 4 times 3 is 12. And we're claiming that 3/12 is exactly the same actual amount of pizza as 1/4, even though they look completely different. It actually represents the same thing. Let's see if this is actually true. So let's take a look at what does 3/12 look like. 1/12, 2/12, 3/12. And actually, I'll just pick this guy up and put it right on top and show you that it's not just close, it's exactly the same amount of stuff. 1/4 is exactly the same as 3/12. So this means exactly the same as this. And so we didn't actually have to change the second fraction at all, so I can just kind of like bring another, bring the 7/12 over here. And I can circle them here, or I can go down here and just write down 3/12 and 7/12. These are two fractions with a common denominator, 3/12 and 7/12. And again, the reason we're doing this is because down the road, when we add these fractions together, the very first step is going to be to get a denominator to be the same denominator between the two. I didn't have to play with this one. I didn't have to change it because I was able to do it by only multiplying one of the fractions. And that is really what you want if you can do it. You want to be able to only have to play around or manipulate one of the fractions. It makes for less work. All right, let's do another problem. Let's take a look at the fraction 5/6, and we're going to compare that, or we're going to talk about the partner fraction 2/3. All right, so we can multiply or divide this fraction by anything we want, as long as we do it to the top and bottom. Same thing here. Notice we have a 6 here in the bottom and a 3 here. Now, I can get everything to match if I just multiply this fraction by 2. Because if I multiply by 2 on the bottom, I'll get 6, that'll match. And 2 on the top, I'll have to do it to top and bottom, but I can get it to match and have a common denominator just by playing around with this fraction. Now, before we actually do that, let's see what this looks like. 5/6 of a pizza. Here's 1/6, 2/6, here's 3/6, here's 4/6, here's 5/6 of a pizza. Let me kind of move it over here, try to get it out of the way. Unfortunately, I can't totally get it out of the way here. But you get the idea. This one can go up here and so on. And the 2/3 is right there. All right, what does 2/3 look like? 2/3, I'll put it right down below. Here's what 2/3 looks like. So you have to remember that where we're going in the future is we're going to be adding these together. It's basically impossible to add them when the denominators are different because the sizes of the slices are totally different. So yeah, we can add them. I can just like say, oh yeah, add it up. It's this plus this. But in order to get an answer, I need to have the sizes of the slices the same. Like these slices became in terms of 12ths, and then this one was in 12ths. And then this one, it was in terms of 8ths, and the other fraction was in terms of 8ths. So it's very easy to add slices together when they're the same size. So you have to get a common denominator to make sure the sizes of the slices are the same size, because later we'll be adding or subtracting them. So what I'm going to do then to fix this problem is I'm going to take the 2/3, and I'm going to start with 2/3, and I want to fix this problem by multiplying the top and the bottom by what? I need to get it to equal 6, right? So 3 times 2 is 6. Multiply top and bottom by 2. When I multiply 2 times 2, I get 4. When I multiply 3 times 2, I get 6. So we're saying that 4/6 is exactly the same thing as 2/3. Let's see if that's right. 4/6. There's 1/6, there's 2/6, there's 3/6, and there's 4/6. Let me just turn it like this. And let's see if we can convince ourselves. Is 2/3 exactly the same as 4/6? We'll just pick it up and put it right on top, and we can see that it's not just close, it's exactly the same amount. So by doing this, multiplying top and bottom, you can see that the fraction meaning, the meaning of what it represents doesn't change. It's like in language, we have different words to describe things. Somebody might say you're beautiful, and somebody might say you're pretty. Somebody might say it's partly cloudy. Somebody might say it's partly sunny. But you see, those really all mean kind of the same thing, right? But we have different words. So it's sort of the same in math. These fractions, 4/6 and 2/3, they look completely different, but they actually represent the same amount of stuff. We only change it to this because that helps us add fractions later, all right? And then, of course, we didn't change this one at all, so we can kind of go over here and say 5/6. So you can see that we turned it into a pair of fractions with common denominator of 6. So if you wanted to circle an answer, you would say 5/6 and 4/6. These are the pair of fractions that have a common denominator. All right? All right, let's take a look at the next problem. All right, let's take a look at the fraction 1/5, and we'll talk about and compare that to 3/10. 1/5, 3/10. All right, first of all, before we do anything, let's see if we can represent and see what 1/5 looks like. If we cut a pizza into 5 equal slices and only take one slice, this is what we have. It's called a fifth. If we cut a pizza into 10 slices and have 3 of those slices, we have 3/10. So here's 1/10 of a pizza, 2/10 of a pizza, 3/10 of a pizza. So that, of course, is a little bit more pizza than the 1/5. Now down the road, we're going to want to add them. So of course you add them together. Look at that, it ends up being a half a pizza. We'll get to adding later. But the point is, we want to represent these two fractions however we can into a common denominator, the same bottom number. I have a 5 and I have a 10. I know that 5 times 2 is 10, so all I'm going to do is multiply this fraction by 2 on the top and on 2 on the bottom. So let's do that. Over here, 1/5. I'll multiply the top of the fraction by 2 and the bottom of the fraction by 2. And what will I get as a result? What will I have? 1 times 2 is 2, and 5 times 2 is 10. And what we're claiming is that 2/10 of a pizza means exactly the same thing as 1/5 of a pizza. Let's see if that's actually the case. Let's go over here. Here's 1/10 of a pizza and 2/10 of a pizza. We're saying that this amount is exactly the same as this. Let's pick it up and put it right on top. These are not close. They're not pretty good. They're exactly the same thing. 1/5 is exactly the same thing as 2/10. And so we succeeded in getting a common denominator because we didn't change this one. This one is still 3/10. So 2/10 and 3/10, I'll just write it down. 2/10 and 3/10. These are the pair of fractions that mean the same thing as the original fractions, but have a common denominator. All right, let's move right along. Let's say, for our next problem, let's say we have the fraction 1/4, and we'll compare that to the fraction 2/3. Or I shouldn't say compare it. What we're going to do is find fractions that have a common denominator that mean the same thing as these original fractions. Now here, first, before we do anything else, let's represent what these fractions look like. So here we have 1/4. That's what 1/4 of a pizza looks like, 1 out of 4 slices. And 2/3 is there's 1/3, there's 2/3. So it's a lot more pizza, the 2/3 right there. So again, later on down the road, we'll be adding them together, of course, and that's how much pizza it will be the final answer. But for now, we're just trying to get a pair of fractions that have the same common denominator. But here, this problem is more tricky because I have a 3 and I have a 4. Now I can multiply this by whatever I want, but 3 times 2 is 6. 3 times 3 is 9. There's no way that I can multiply and get 4. And then I also see that 4, I can multiply this by, let's say 4 times 2 is 8. 4 times 3 is 12. There's no way I can get this to equal 3, and there's no way I can get this to equal 4. So what do you do? Well, what you have to do is, instead of, like in the previous problems, we just changed one of the fractions. Here, we're going to have to change both of them. See, before it was easy. All I had to do was multiply this times 2, and it became 6. That's a match. Multiply this times 2, and it became 10. That's a match. I only had to do one fraction. Here, I can't, so I have to do both of the fractions. So then you have to say, what denominator am I going to shoot for? Now, most books are going to tell you just to find the least common multiple. And you can shoot for the least common multiple to be your denominator. We just learned about the least common multiple. So I think it's fine if you want to find the least common multiple. But I actually prefer to teach it in a little easier way. Look at these numbers. Think of your multiplication tables. We have to have the same common denominator. We can't pick 8 because 4 times 2 is 8, but there's no way I can multiply this to get 8, right? I can't pick 9 because even though 3 times 3 is 9, I can't multiply this and get 9. But if I think of the number 12, just kind of go up through your multiplication tables, 12 works because 4 times 3 is 12. And down here, 3 times 4 is also 12. So I can get a common denominator there. So let's try it. Okay, and let's say I have 1/4, and down here I'm going to change the 2/3. So basically I'm going to have to change both of these fractions. All right, what do I do here? I want to multiply, I'm shooting for a common denominator of 12. So I multiply this times 4 and this times 4. And what does that make? 2 times 4 is 8 and 3 times 4 is 12. Up here, I also am shooting for a denominator of 12. So I multiply by 3 and by 3. And so 1 times 3 is 3 and 4 times 3 is again 12. Notice what we're saying. What we're saying is that we change this fraction into something new. And we change this fraction into something new. But the meaning of these fractions are the same amount of stuff as the meaning of these fractions. They just look different. But now they have a common denominator, which we have to have in order to add them, which we're going to do later. So let's see if we can convince ourselves that this is actually true. So let me grab my twelfths. We're saying this is 3/12. Here's 1/12, 2/12, and 3/12. And then down here is 8/12. Here's 1, here's 2, here's 3, here's 4. Here's 5, here's 6, here's 7, 8/12. So let's see if this makes any sense. Is 1/4 the same as 3/12? It's exactly the same. So yes, that is a match. Is 2/3 the same as 8/12? Let's see if they match up. Of course, they're sticking out a little bit because I'm not perfect, but they are an exact match as well. So we can see that the two fractions here, they mean the same thing as what we started with, but now they just have common denominators. So you can circle as your answer 3/12 and 8/12. These two fractions are the two fractions with common denominators that mean the same thing as our original problem. All right, for our next problem, let's take a look at the two fractions. First one is 2/3. And the second fraction is 1/2. We want to find a pair of fractions that mean the same thing as these fractions but have a common denominator. First, before we do anything else, let's represent 2/3. 2/3, in terms of actual amount of pizza or whatever, is, there you go, 1/3, 2/3. That's what it is. And then 1/2 is exactly what you would think is. This is a half of a pizza. So this is the amount of stuff that we have here. Now, how can we actually change this? We have a 3 and a 2. There's no way that I can just manipulate only one fraction because 3 times 2 is 6 and 2 times 3 is 6. So I can't change just one to equal the other. But I just answered my own question because when you think through, you can go find the least common multiple and all that works out great. But really, if you just think through, I need a common denominator. I know that I can pick 6 because 3 times 2 is 6. And 2 times 3 is also 6. So as long as I can pick a number for a denominator that I can change both fractions into, then I'm good. So I'm going to pick 6. And so what I'm going to do is change this 2/3 into something. And I'm going to change this 1/2 into something as well. And I'm going to choose a common denominator of 6. That means I need to multiply this times 2 and this times 2. And then I will get 2 times 2 is 4. And 3 times 2 is 6. So 4, 6, we're saying is the same thing as 2/3. Here, I'm going to multiply this one times 3 and this one times 3 because, again, on the top will be 3. And on the bottom, 2 times 3 is 6. So now I have a common denominator, both of 6. Now let's see if we're convinced that this actually works. So let me grab my 6th here. This is 1/6, 2/6, 3/6, and 4/6. And I can rotate it like this. I don't think I need to like pick it up and put it on top. But you can see that this is exactly the same amount as this. And then here we have 3/6. There's 1/6, There's 2/6 and there's 3/6. And I think you will agree that this is exactly the same thing as half. So this means the same as this, and this means the same as this. So these fractions are equivalent, and these fractions are equivalent. And so if the goal of the problem is to find a pair of fractions with a common denominator, 4/6 and 3/6 are the two fractions that you want. When we add fractions later, the first step is going to be to get this, and then I'll show you later how to actually add them together. All right, now I think we've done enough with magnets. We don't need to do any more magnets. Let's now convert or change these fractions as we need to have a common denominator. 5/16, and let's take a look at 3/8. All right, so we have 16 and we have 8, but I remember immediately that 8 times 2 is 16. So I only need to change the second fraction. Here, how do we do it? Just rewrite it. 3/8. What do I need to multiply the top and the bottom by? Well, multiply by 2, multiply by 2. On the bottom, 8 times 2 will be 16. That'll match here. And then 3 times 2 will be 6. And this fraction, I didn't need to change at all. 5/16. So 5/16 and 6/16 are the right answer. So instead of rewriting it, I'll just circle these two fractions. The goal is to find two fractions that mean the same thing as the original fractions that have the same denominator. And that's exactly what we ended up with. All right, just a couple more problems. Let's take a look at the fraction 3/8, and let's take a look at the fraction 1/6. I need to get a common denominator, right? I cannot change this one into an 8 by multiplication, and I cannot change this one into a 6 by multiplication. So I'm going to have to pick something else. And you need to kind of just think, you can find the least common multiple. We've done that before. That's going to be the denominator you should shoot for. But finding the least common multiple is kind of a pain also. So instead, I just want you to think, well, I know that 8 times 6 is 48. So I know that I can pick 48 as a common denominator. I'd multiply this times 6 and 6, and I multiply this one by 8 and 8. And I would get 48 as my new common denominator. That's okay, but is there anything smaller than that? And if I think hard enough, I realize, wait a minute, 8 times 3 is 24. And also 6 times 4 is also 24. So that's a smaller number that's going to be a better common denominator. So let's convert. We have 3/8. And I want to have a denominator of 24. So I'm going to multiply this by 3 and then this by 3. 8 times 3 on the bottom is 24. 3 times 3 is 9 on the top. All right, let's change this one. 1/6. And so what do I have here? Well, let's change the color over here. I'm shooting for 24, so 6 times 4 is 24, and then I have to do that on the top as well. On the top, 1 times 4 is 4, and 6 times 4 is 24. Now what we're saying is that 4/24 is the same as this, and 9/24 is the same as this, and that's exactly right. And so these fractions have a common denominator and represent the same thing, but they just have the same denominator, which is what we need for adding fractions later. All right, I think we only have 1 or 2 problems left. Let's take a look at the next problem. Let's say we have 5/6 and the fraction, the partner fraction, 1/9. Now I have a 9 here and a 6 here. What can I do? I cannot just manipulate one of these fractions because 9 and 6, I can't turn this into a 6 and I can't turn this into a 9. And I know as a last resort, you can always pick a common denominator to be 9 times 6, which is 54. Because I can multiply this times of 9 over 9, 9 on the top and 9 on the bottom. That would give me 54. And this I could do 6 and 6 on the top and bottom. That would give me 54. So that will work. But is there anything smaller? And you can go find the least common multiple if you want. But if you just think through, 6 times 2 is 12. 6 times 3 is 18. But I also know that 9 times 2 is also 18. So I'm going to choose 18 as my common denominator. It's a smaller number that fits the bill. So choosing 18 as my common denominator, I multiply this times 3 on the top and 3 on the bottom. 15 goes on the top because 5 times 3. And then 6 times 3, 18 on the bottom. All right, this one I'm going to change as follows. I'm going to change it as multiplying by 2 on the bottom and 2 on the top. Because I'm shooting for 18 as a denominator, right? 9 times 2 is 18. And on the top, 1 times 2 is 2. So what we're saying is that 2/18 is exactly the same thing as 1/9. And 15/18 is exactly the same thing as 5/6. And because now I have the same amount of stuff represented with a common denominator, I can just say, well, I'm done. And these two fractions are going to be the ones that I'm going to circle for my final answer. All right, we only have one last problem. I think we can squeeze it in over here without too much problem. Let's take a look at the fraction 7/8 and 7/12. So what do I have? 8 and 12. I have to manipulate both fractions. Just start thinking through it. 8 times 2 is 16. That doesn't work with that. 8 times 3 is 24. But I also remember that 12 times 2 is 24. So that's bingo. I have to pick a number that I can manipulate both fractions with multiplication to get there. So I'm going to shoot for 24. So this one is 7/8, and I'm going to multiply by something to give me 24. Multiply by 3 and by 3. And what does this equal? On the top, 7 times 3 is 21. On the bottom is 8 times 3, 24. And then over here, it's going to be 7/12. What do I need to multiply by? 12 times 3. I'm sorry, not times 3. 12 times 3 is 36. Everybody makes mistakes, especially when you're tired. Times 2 and times 2. So on the bottom, 12 times 2 is 24. And on the top, 7 times 2 is 14. And so I'm saying that the fraction 14/24 is the same as 7/12. And the fraction 21/24 is the same as 7/8. So these fractions are not different, they just look different. But now they have a common denominator. So in this lesson, we've worked quite a few problems dealing with common denominators. And so all we want to do is manipulate sometimes, hopefully, only one of the fractions, but a lot of the time you have to multiply or manipulate both of the fractions to give me new fractions that represent the same thing but have the same denominator. Because when we add fractions, before you do anything else, the first thing you have to do is get a common denominator. So we're going to get very, very, very good at it. And I'd like you to solve all of these problems, and then follow me on to the next lesson. We'll continue your skills with common denominators. Learn anything at mathandscience.com.